These days, as we all know, that AI data centers are burning through billions in GPU investment, but there is a hidden tax on all that compute the network. I mean, when we look at traditional data centers, we talk about compute, we talk networking, of course, we talk about storage. But in AI terms, we are all obsessed with GPUs. And while, yes, GPUs have exploded in capacity, the switches and interconnects moving data between them are lagging behind. It's more like you have nice cities, but if your highway is not done, you cannot have traffic there. That's what exactly network does. It creates something which is called network wall. It throttles performance, it drives up latency, and it forces organizations to settle on 50% or less GPU utilization because they can't get access to it. To deep dive into why this bottleneck has become one of the most critical challenges in AI infrastructure, today we have with us two guests from Eridu, Perkins, CEO and founder, and Omar Hassen, CPO and founder. Omar, Drew, it's great to have you both on the show.
Thank you for having us, Swapnil.
Thank you, Swapnil.
It's my pleasure and honor. Before we deep dive into this problem area, I would love to know a bit about the company itself because I'm lucky to have two founders here. So talk about the company.
Well, Eridu is a company that I started thinking about a little bit more than 3 years ago. And I started recruiting co-founders and employees about 2.5 years ago. Omar was the very first person to join me on this journey. And about 2 years ago, we started raising money, and we raised money from some of the very best and brightest in Silicon Valley, including a legend in Silicon Valley. Pierre Lamond was one of our very first investors. We're very excited about that, but we've had other great investors along the way. We've now raised well over $200 million for the company, and we've built an incredible team. Omar was the first person to join me, but we now have over 140 people and many other people that are other serial entrepreneurs like the two of us, and people that have built multi-billion-dollar products and built multi-billion-dollar companies. So we just have an incredible team of people, and we're attacking a very, very big problem. This problem of building the network for AI superintelligence. This concept, we're going to have this machine very soon here that's smarter than all of us combined. And it takes new networking technology to do that. And that's what we're out to do it. And we're doing it with the greatest partners in the world, including people like TSMC. And we're doing it for the biggest companies and movers in the world, all these hyperscalers out there. And we think this is going to be very, very important and a great contribution to technology, to society, to our culture, business, etc. Omar, what else can you add?
I think you pretty much covered it, Drew. I think the premise here is that networking is becoming a drag rather than enabler, and we're here to fix that. We're going to enable all these GPUs to work together as one machine, as the algorithms intended, to enable superintelligence.
Thank you so much for sharing the vision of the company. I would love to know a bit about the challenges. As you know, we all know we get obsessed with GPU. Everybody is running after GPU, but how to get to the GPU? That's where the network. So talk about what are the constraints that the current breed of network is posing, which also, whether we talk about superintelligence, hyperscalers, they can scale things up and down very quickly. But talk about what is the exact bottleneck that network is creating where organizations are actually not able to access what they're paying for.
So networking technology, in particular Ethernet switch chips, have been doubling in capacity every silicon node. Every time we've gone from 7 nanometers to 6 nanometers, 5 nanometers, 4 nanometers, etc. These switch chips have been doubling in capacity. But the GPUs have been growing far faster than that. And there's a variety of reasons for that. But GPU and computation has been growing in need requirements far faster than networking has been able to support it. And so we think that causes a problem because the GPUs need to ingest data to process this data very quickly, but they can't do that if they don't have the data. And the network is just not keeping up with the needs and being able to feed them that data as fast as possible. So our observation is that we need to find a way to let the network keep up with the computation side of the system. And that takes new technology. So our goal has been to rethink how the network switches are built, how the whole network is built, including the silicon, the packaging, the whole system, the optics, everything together to feed data to the GPUs and allow them to intercommunicate with amongst themselves at the same rate at which they're able to process that, and to be able to keep up with the rate of growth that the computation side has been having. And that just fundamentally requires rethinking everything to plan for that level of growth. And that's what Eridu has been about from the very beginning.
Excellent. But if you look at this hardware space, there are some of the smartest companies out there building all these network switches. So what is the exact problem that even all these well-established companies who have been in space for decades or hundreds of years, why couldn't they solve this problem? Why needed a new company to come and solve this problem? Is it a new approach? Is it about being able to move faster? What is the reason?
I think the networking industry has grown complacent over the last several decades. That 2x every 2 years, 2x every silicon node, keeping up with Moore's law has been good enough. And they've just grown used to that, and the whole industry is based on that. And, NVIDIA just hasn't let that happen. In the CPU space, CPUs were also doubling in performance, and that's why with Moore's law, and that's why the networking was doing that. But GPUs came about, and they said, that doubling is not good enough. We need to grow 10x every couple of years instead. And the networking guys didn't, get that message, and didn't keep up. 2x has been good enough. The whole industry has worked really well economically, financially, etc. But we observe that, the computation people and industry is leaving the network in the dust. And we were I don't know if we were first to notice it, but we were the first to do something about it and try to rebuild a company from the ground up designed to keep pace with the computation side.
And what exactly is your approach to solve this problem? New chip designs, new approach to networking altogether. What is that?
Literally is to look at everything from the ground up, from literally how a semiconductor is made and how are they packaged and everything. But in particular, with the massive growth in the numbers of GPUs in the AI data center and the way that they ingest data, we realized that what you needed is networking switches that have higher radix, higher number of ports that can allow you to build a network that is flatter, that is higher performance, that is lower latency. And we're attacking all those problems at every level that we can in order to achieve that goal, to achieve a faster network to keep up with the GPUs.
So does it mean that you would need a purely clean sheet design, or you are tweaking the existing switching technologies?
It just required us to just rethink how the chips are built, how they're architected, how the packages of those chips is done, and how you could possibly build something with higher radix, a higher number of ports that is a flatter network. So we have not gone into the details yet, haven't disclosed the full details of this, but leave it to be said that what we're doing here is just a more scalable network that is designed for scalability more so than today's networking switches.
Who would be the ideal target audience when we talk about, of course, the whole networking? Is it going to be organizations like Anthropic or OpenAI, or is it going to be hyperscaler? Is it going to be neocloud? Is it going to be consumers? Who is going to impact, or it's going to impact everybody? Because just the way if you get a new chip, it's going to not only help consumer, it's going to help everybody. So what impact there will be, on AI initiatives, AI data center? How will it affect?
So our primary customers are the hyperscalers that are deploying the GPUs and the networks that interconnect them, building these data centers. Of course, those are being used then by the people building the models the OpenAIs, the Anthropics, but of course Google is kind of both combined in that case, and Amazon to some degree and Microsoft to some degree, et cetera. But fundamentally, it's the organization that is designing the GPU and data center system.
Will it augment, complement, or it will replace the existing lower radix switches? Just walk through when your technology, when your product is actually, Omar, you can also jump in there. How would it look like?
In addition to the performance benefits that Drew outlined, you also get some additional benefits from the higher radix. And these include lower network power. As it stands today, the network, the amount of power being used by the network is growing because you need multiple layers of these smaller switches. And that's essentially taking away power from the compute, which is where the tokens are generated. And this is where the data centers are actually creating economic value. So by lowering the network power, you can create more tokens by virtue of having more compute use up that power. Additionally, the other issue that's happening is that the cost of the network is growing as a percentage of the IT spend in a data center. So right now, it's kind of crossing over 25%, in some cases getting almost 30%. And with our solution, we're able to reduce the network power by 70% and the cost of the network by about 40%. So that's a significant amount of capex and power that can be dedicated to economic benefit of the data center operator. So we're adding value not only on the performance side, but on the economic side as well.
Based on the studies, how much do you feel that organizations are not able to leverage the capacity of GPU because of network? Do you have any data there?
Yeah, there are a number of studies that have been published. Meta, in particular, has done some great work in measuring this and providing and publishing real results, real measurements on that.
If you look at what other companies like NVIDIA are saying, specifically Jensen Huang in his keynotes, he mentions how the network can help improve performance. He said in some cases, he stated up to 25%, and how even a 10% improvement in network performance results in billions of dollars in economic value in these data centers. So there's a, I would say, industry-wide recognition that the network performance directly impacts the performance of the compute in the data center.
If you look at, we can call it next generation networking, whatever, I don't want to find a new term, but is it more or less like evolution of how we are? I mean, we live in a cloud, data-driven, API-driven world, so that's where we are living. Is it that kind of natural evolution where network should be, or because of AI and the kind of stress it is putting on networking that the new approach is needed?
I think that there's a fine line between evolution and revolution. And when evolution moves at a very much faster speed, I think it looks more like revolution. And we're trying to move things at a faster pace than have historically happened here, and bring more new technologies to bear more quickly. And so you might look at some of the things we're doing as revolutionary, or you might look at them saying you're just evolving faster. But in any case, our goal is to bring new technologies to bear to market faster than would otherwise have been happening, and improve the network performance faster than would happen without us here, and really grow this into a fantastic leading company by doing so.
Drew, Omar, thank you so much for sharing these insights where we should be heading with networking. But I look at this discussion more of a teaser. I'm actually looking forward to the next one where we can start talking technology, because that's what I love to talk about. But I really appreciate your time today, and I look forward to chat with you folks again. Thank you.
We appreciate your giving us this time, Swapnil. Thank you so much. And we look forward to talking with you again in the future.
Thank you so much.